So last class we talked about our congruent shortcuts for determining if two triangles are congruent, the side, side, side. So last class we had our side, 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 and side angle, side congruent shortcuts. There are 4 shortcuts though, and so today we're going to talk about the second 2 called angle, side, angle, and angle, angle, side. So when we talked about an included angle from last class, today we're going to need to talk about an included side as a part of our vocabulary here. So a side that is between 2 consecutive angles in a polygon is called an included side. What do we mean by that? Well, just like with the included angle, we have a side, in this case, that is between angle B and angle C. So what side is between angle B and angle C? Well, that would be side BC. So that would be called the included side. We're going to use that vocabulary term as we go through this particular section, and the next congruent shortcut uses that. So if 2 angles and the included side of one triangle are congruent to the 2 angles and the included side of another triangle, then the triangles are congruent. So for example, if we're referring to our angles here, we've got angle A right here is congruent to angle D in our second triangle. All right. Then we have a side that is included between those. So the side that we're talking about here is side AB, and side AB is congruent to side DE in our second triangle. And then we have our other angle. So we've got angle B in our first triangle that is congruent to angle E in our second triangle. So if we follow that order, we have an angle, we have an included side, and then we have another angle. And if that's true, then all of the rest of the parts that are not marked, these 2 sides and this angle, would also have to be congruent to each other because that is a congruent shortcut. So then we can say a triangle, let's say BAC is congruent to triangle. So if BAC, then that would be EDF in our second triangle. So we're going to use that congruent shortcut in a proof down here below in example number 1. So angle, side, angle. So let's think about again what we're trying to prove. We're trying to prove in this case pretty straightforward. We're trying to show that those 2 triangles are congruent to each other. Let's start off with our givens, and in this case we'll do a statement and reason 2-column proof here. And so let's first think about what we are given here. So we've got our, I'm actually do this one first. We've got angle PSQ congruent to angle RSQ. So that is a given. So let's just look at that one. PSQ, RSQ. So we're talking about this angle and that angle right there. Okay. Our other given is that segment QS bisects angle PQR. So that's our other given. Now that doesn't directly tell us that anything is congruent. So we can't mark anything into the diagram quite yet. But what does it mean for QS to bisect angle PQR? Well, the definition of bisect means to split into 2 equal parts. So an angle bisector, so this segment is bisecting the angle, so it's an angle bisector, splits that angle into 2 congruent parts. So because of that, we know that these 2 angles are congruent to each other here and here. So we can then say angle PQS in the top triangle is congruent to angle RQS in the second triangle. Definition of angle bisector. So now notice you're keeping track of your angle, side angle. We have a couple angle pairs that are stated as congruent, but we don't have the sides. So let's look back at the diagram. Notice both of these triangles share side SQ. So if they both share side SQ, we can mark SQ as congruent to itself. So SQ is congruent to, well, let's just make sure we've got the same corresponding parts. So if we say SQ in the top triangle, it actually works the same in the second triangle. So corresponding parts still match up. So SQ is congruent to SQ. So there's our reflexive property of congruence, POC, property of congruence. So now I have all of the necessary parts. So I can go ahead and say, as a final statement, that our triangle PQS is congruent to triangle RSQ. Oh, sorry, not RSQ. Back up, RQS. Keeping track of naming everything with the right corresponding parts matching up. So those two triangles are congruent to each other by the angle-side-angle congruence shortcut. So similar to the proofs that we were doing last time, you've got 4 or 5, sometimes 6 steps in there, but the key is to have 3 congruent statements somewhere in there that match up to our congruent shortcuts. So the ones that I've starred here are congruent statements, and then we can go ahead and make the triangle congruent statement as our last step down below. All right, so let's move on to the second page, and this will be the last of our 4 congruent shortcuts. And so this one is called an angle-angle-side, or side-angle-angle. You can go in forwards or reverse. But don't mistake it for the ASA shortcut. Notice that where that side is stated in here is no longer included like it was on the first page. On the first page, angle, side, angle, that side had to be between the 2 angles. Here, the side is not going to be between the 2 angles. And so when we say that is true, we use the term non-included. So let's write that into our notes. So the 2 angles, if 2 angles and the non-included side of one triangle are congruent to 2 angles and the non-included side of a second triangle, then the triangles are congruent to each other. So let's keep track of where those are. So let's come back to, let's see, angle A here would be congruent to angle D in our second triangle. And then the next angle, the angle B, is congruent to angle E. And then we have the side that follows. BC is congruent to, let's see, BC would be congruent to EF. So there we have our order, and notice it's angle, and then the side. Angle, angle, and then the side. Angle, angle, and then the side. So that is where the congruent shortcut is different than the angle, side, angle. Notice the side is no longer included. If it was included, the congruent side would be in these couple spaces here between the 2 angles. So now we can say something like triangle ABC is congruent to triangle, let's see, ABC corresponds with DEF, I guess, in this case. So we're going to do a proof related to that in example 2. So if you look at this diagram, it's at first a little confusing because we've got a number of overlapping triangles. We are going to prove that triangle ACD is congruent to ECB. So let's just outline those 2 triangles. So ACD is this triangle right here, right? ACD. And so I'm actually going to sketch it out here separately, and I'd like you to do the same and label it ACB. And we're going to show that that is congruent to triangle ECB. So ECB is this triangle right here. So I'd like you to also sketch that one out separately so we can keep track of it just a little bit easier. And put the names of the vertices over there as well. All right, we're going to show that those 2 triangles are congruent, and just like before, we're going to start with our congruence statements, our givens, and let's do this one in a flowchart format. So DAC is congruent to BEC. that's a given. So I'm going to mark that in the diagram now. Feel free to pause this if I'm going too fast. That's the nice thing about the video virtual, Mr. Swigum. Pause me, rewind me. Do not fast forward me. Please do not fast forward. That would not be the right thing to do. All right, so we get back on track here. So DAC, BEC, so those two angles right there and there, right? So those are congruent to each other. And then we've got DC is congruent to BC. It's another given. So DC and BC are congruent to each other, so we'll mark that. Now, we're thinking about our angle side. Notice that we have a side and we have an angle, but we need that other angle, it looks like. So looking into the diagram now, do you see how that's going to work? It's a little bit hard to see actually in our separate sketch. We're going to come back to the original diagram. Notice both of these triangles share angle C. Okay? So that's actually going to be the congruence statement that we're going to make. Angle C in the first triangle is congruent to angle C in the second triangle. And once again, that's our reflexive property of congruence when something is congruent to itself. So I'm going to mark that in the diagram here. So this angle right here is congruent to this angle right here. So angle C is congruent to itself. And so once we have that, notice that now we have enough information to say that these two triangles are congruent to each other. Getting really colorful with my flow chart here. What should we go with? Green next? Where should we go? Yeah, let's go green. So now we have, notice our angle, angle, and then the side. Angle, angle, and then the side. So the two triangles are congruent to each other by angle, angle, side. So ACD, triangle ACD, is congruent to triangle ECB by angle, angle, side, or if you prefer, side, angle, angle. And all of our congruent statements lead to that. So in this case, we just had our congruent statements that were given right from the start, and then that shared angle. So we only have 4 steps to that. So let's summarize then our 4 congruent shortcuts. We've got side, 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 which is the easiest one to remember. Side, angle, side is probably the next easiest to identify. These two can sometimes be confused though, the angle, side, angle, and angle, angle, side. So just be clear about that. Notice where the included side is. Is it between the 2 angles? Then it's angle, side, angle. Is it not included between the 2 angles? Then it's angle, angle, side. So those are the 4 congruent shortcuts that prove that all of the rest of the parts would also have to be congruent. The 2 that are not, we haven't focused on this as much, but the 2 that are not are basically the letter combinations that are left here. You need at least 3 parts to show congruence, but with these 3 parts, you don't guarantee congruence. So if we have side, side, angle, where the angle is not included between the 2 sides, and that is congruent to the second triangle with the same 3 parts, notice that even though these 2 triangles have the same 3 parts, they are not exactly congruent. So side, side, angle does not prove congruence. Now, in reality, there's only a couple triangles that could possibly happen with these same 3 parts with side, side, angle, but it does not guarantee that they are congruent. So we cannot say that that's a congruent shortcut. So remember that one. That's the one that spells the naughty word backwards. So we'll spell it side, side, angle. But if you'd like to do angle, side, side on your own paper and get a little laugh out of that, then just don't show that to me. Put side, side, angle on the test. Thank you. The other one is angle, angle, angle. Now there's actually an infinite amount of triangles that could have the same 3 angles but would not be congruent. These particular triangles would be a scale factor difference and would actually be called geometrically similar, but they would not be congruent to each other if they have the same 3 angles. So technically the best answer is probably cannot be determined, because it is possible they could be congruent, but they're most likely not congruent if they have those same 3 parts. This would be great note card material for you guys at the end of the unit here, your 4 congruent shortcuts and your 2 that are not congruent.